Hello, this is Dr. Mateki. The purpose of this video is to walk through the solutions to problem number 2 on the Unit 2 homework. First, I just have some general comments. So this problem explores the concept of a social welfare function. A social welfare function is an equation that shows how the well-being of society depends on the well-being of its members. The governing body of a society presumably would like to make society as well off as possible. So that would require understanding how we should allocate resources. In this case, we're talking about burritos to members of society to achieve the goal. Social welfare functions are born out of the various philosophies of how we should treat and value different members of society. These ideas are subjective, and no particular social welfare function is demonstrably better or worse than another. Kind of just depends on your worldview. Social welfare functions are limited in what they can do, mainly because it is impossible to measure the utility of each member of society, and interpersonal comparisons of utility aren't really possible either. My really happy may be completely different from your really happy. We can't really get inside each other's heads and understand what that really means. So, while we cannot really use a social welfare function to make decisions and give precise answers to questions of resource allocation, I still think it's a useful tool for just thinking about the different approaches to government activities like taxing, redistribution, that sort of thing. So in a qualitative way, it helps us think about what different social philosophies imply for government policies, how policymakers should act. So now let's talk about this problem specifically. So to have a value to feed into a social welfare function, we need to define how individual utility, and so when I say utility, I'm just talking about happiness, well-being, etc., however you want to think about that, how utility depends on consumption. So in the real world, your utility would depend on the consumption of lots of different things, thousands of goods and services. But here we're just simplifying down to a single thing, burritos. So the utility function here indicates that an individual's utility level is the square root of the number of burritos they consume. So you can see that highlighted in green here. Our utility function, so when we have u parentheses b here, that just says that utility is a function of b, where b is the number of burritos, is equal to b raised to the 0.5 power. That's the same thing as taking the square root of b, but when we're typing a formula into Excel, if we want to take the square root of something, the easiest thing to do is just type b caret 0.5. So given that relationship between consumption and happiness, now let's move on to some of the different philosophies of social welfare and the equations that they imply, the social welfare functions. So utilitarians, question number 1 deals with utilitarians. So they believe that all members of society should be valued equally, implying we should just simply add up all of the individual utilities to arrive at social welfare. So the utilitarian social welfare function is highlighted in blue here. So SWF just stands for social welfare function, and I'm just using U sub U to represent that. For the U is for utilitarian. So the utilitarian social welfare function is adding up all of the individual members. So we're just taking the utility of Cheech and adding it to the utility of Chong. If we are a Rawlsian, the second question asks us to look at social welfare for a Rawlsian. So a Rawlsian believes that society is only as well off as the least well off member. So in other words, society is no better off if the rich keep getting richer, if the poor don't also get richer. So this implies that we should only look at the smaller of the two individual utilities. So that means we should look at a min type of function. So we're going to look at the smaller of the two utilities given by utility Cheech and utility of Chong. So we're just going to figure out which one of those two is smaller, and then that becomes society's well-being. And finally, we have question 3. So we're going to try to maximize social welfare using a weighted social welfare function. And so, in the case of a weighted social welfare function, not all members of society are counted equally when we add them all up for, or when we aggregate them to get social welfare. So perhaps you think that children should be valued more than adults, or vice versa, or that working age members of society should be valued more than retirees, or any other number of possible different philosophies. And note, not judging or valuing any of those, I'm just giving you potential ways that we might value people differently. So in this problem, we are saying that Cheech's utility is weighted twice as much as Chong's utility. So lucky Cheech. And so that puts us at this equation that you see highlighted in sort of yellow here. So the weighted social welfare function is just going to be 2 times the utility of Cheech plus the utility of Chong. So Cheech is weighted more heavily. All right, so given all of those equations and definitions, let's proceed down to a little table that I've created here to start doing some calculations. So we can see here in columns D and E, we have the utility for a given allocation of burritos. And so, again, when I say allocation, this is just how we're deciding to divide up the burritos between the different members of society. So in this case, we only have 2 people, so it's pretty easy to figure out. If we have 8 burritos possible, or 8 burritos total, excuse me, then we have the following possibilities. So we can give none to Cheech, give them all to Chong, and then we can start dividing them up in various ways. This allocation here is when we give each person the same number of burritos, 4 and 4, and then down at the bottom, we're giving everything to Cheech, and Chong has nothing. So columns D and E again give us, we're going to calculate the utility. So the utility is based on the utility function that was given above. Remember, it's the square root. So I'm just going to go ahead and program in some formulas here. So the utility of Cheech is going to just be equals, I'm going to grab cell B32 here, and I'm going to raise that to the 0.5 power. So we're taking 0 and raising it to the 0.5 power, which of course is 0. So for Chong, we're going to take cell C32, which we're going to also raise that to the 0.5 power. Okay, so Cheech has 0 utility because he had 0 burritos, and Chong has utility level of 2.83 roughly, based on the 8 burritos that he consumed. So now the nice thing is we can just grab these formulas and drag them down to get the utility levels for all different possible combinations of burritos. Okay, so I'm just going to bring this down here a little bit to get some of the decimal places out of there. Okay, so given these utility calculations, now we can go to our social welfare functions and see which combinations of burritos or which allocations are going to yield the highest social welfare given these different philosophies that the social welfare functions embed. So utilitarians, remember, all we're going to do is simply add up the utilities of all the members. So we're going to grab this cell here. Well, first I'm going to type equals. So then we're going to grab the utility of Cheech, and we're going to add it to the utility of Chong. And that's it. So social welfare is 2.83 in this case. It's the sum of Chong's utility and the sum of, the sum of Chong and Cheech's utility. So then we can grab that and copy it down as well. Okay, and so if we're a policymaker and we're trying to make society as well off as possible, what we want to do is maximize the value of this social welfare function. So we're going to go and look at all the values, and it looks like our social welfare is maximized right here at a value of 4, and that happens when we have an equal allocation of burritos. So the utilitarian policymaker would strive for an equal distribution of resources here. Now, a Rawlsian is going to look at the smallest of these 2 utility values in columns D and E, and that's going to be the measure of the social welfare function. So we're going to do a min function, which Excel makes it very easy to identify the smallest number in a group. So I'm going to type equals min, then parentheses, and I'm going to grab these 2 cells, And then Excel is going to show or pick out which one of these two values is smaller. Probably don't need it for this particular example, but if we had lots of values, this formula is pretty useful. So once again, we can drag it down. Okay, and so again, so if we're a Rawlsian, we want to use this formula to identify the allocation that yields the highest social welfare. So we again examine these values here. We can see that once again the highest social welfare comes at the 4-4 allocation. So whether utilitarian or Rawlsian in this case, you know, the idea here should be to strive for equal equal distribution of the burritos. All right, weighted social welfare. So this is where some members of society are valued differently than others. So we're going to program in this weighted welfare function that we had up here in cell D17. So we need to multiply Cheech's utility by 2, and then we are going to add it to Chong's utility. Okay, and so then I will drag this formula down, and I just don't like all those decimal places, so what we're going to do here is, again, try to identify the highest value, and if you want, you could always do an equals max formula to identify which of these values is biggest. That's not really necessary here, though. We can just look down and see that the ideal allocation here is to give 6 burritos to Cheech and 2 to Chong. So interestingly, notice that even though we are weighting Cheech more heavily, the ideal allocation is not to give all the burritos to Cheech and nothing to Chong, right? So the idea here is this utility function that we've programmed in here, it exhibits diminishing marginal returns. So just like we would normally suspect that as you consume more and more burritos, each additional burrito contributes less and less to your happiness. So giving Chong 1 burrito when he has none is more beneficial than twice the amount of happiness Cheech gets from adding, you know, the 7th and 8th burritos, because he already has quite a few. Okay, and so that wraps up the exercise here. So again, we have identified the allocations of burritos that maximize social welfare based on 3 different philosophies.